In the last lesson, we learned about numbers and math operations in Python. In this lesson, we are going to learn something that will make our programs much more interesting, which is getting input from the user. So far, every program we have written has been fixed. The values we are already written inside the code, and the program just displayed them. But real programs are not like that. Real programs interact with user. They ask for information, the user provides it, and the program uses it to do something. Think about when you open an app on your phone and it asks you to enter your name or your age. That is user input. The program is asking you for information. In this lesson, we will learn how to do that in Python. Let's open the terminal and go to our working directory. Let's create a new file for this lesson. Let's name it learninginput.py. Press I to switch to the insert mode. Then let's type some codes. Press escape, then save. Now let's run the file. You can see that the program is now waiting. It printed the question, "What is your name?" and it is waiting for you to type something. Let me type my name and press enter. You can see that it printed "Hello, additional." That is user input in action. The program asked a question, the user provided an answer, and the program used the answer to display a message. Now let me explain how input works. The input command tells Python to pause the program and wait for the user to type something and press enter. Whatever the user types is captured and stored in a variable on the left side of the equal signs. So in our example, name is equal to input open bracket, open quotation mark, what is your name, question mark, space, close quotation mark, close bracket. Whatever the user types will be stored in the variable name. The text inside the brackets, what is your name, is called the prompt. It is the message that appears on the screen to tell the user what to type. Notice the space I put before the closing quotation mark in the prompt. That space is important because without it, whatever the user types will appear right next to the question mark with no space between, which looks untidy. Now, here is something very important you need to know about input. Whatever the user types, Python always treats it as a string, even if the user types a number. Let me show you what I mean. Let's update the file. Let's print the type of age. Press escape, then save. Run the file. The program asks of your age. Let me type 26 and press enter. You can see that it printed class string. Even though I typed a number, Python stored it as a string, not as an integer. Why does this matter? Because if you try to do math with it, Python will give you an error or unexpected results. Let me show you. Press escape, then save. Run the file. Let me type 26 and press enter. You can see that it gives us a type error. It says that you cannot add an integer to a string. This is exactly the problem. Python cannot add a number 1 to a string 26 because they are different data types. To fix this, we need to convert the string into an integer first. In Python, we can convert one data type to another. This is called type conversion or typecasting. To convert a string to an integer, we use the int function. To convert a string to a float, we use the float function. To convert a number to a string, we use the str function. Let me show you how to fix our program. Let's update the file. Press escape, then save. Run the file. Let me type 26, then press enter. You can see that it now printed on your next birthday, you will be 27. The program works correctly now because we converted the string 26 to the integer 26 using the int function before performing the math. Notice what we did on the second line. Age is equal to int age. We took the value of age, converted it to an integer, and stored it back into the same variable age. Don't get confused. This is a common pattern in Python. There is also a shorter way of writing this. Instead of doing the conversion on a separate line, you can do it directly on the same line as input. Let me show you. Press escape, then save. Let's run the file. Let me type 26 and press enter. You can see that it gives the same correct results. This is the more common way programmers write it, wrapping the input function directly inside int function on the same line. Now let's practice more. Let's build a simple program that asks the user for two numbers and then performs all the math operations on them. Let's create a new file. Let's name it usercalculator.py. Press I to switch to insert mode. Then let's type some codes. Press escape, then save. Let's run the file. Let me enter 20 for the first number and then enter 4 for the second number. You can see the results. Addition gives 24.0, subtraction gives 16.0, multiplication gives 80.0, and division gives 5.0. Notice that we used the float function instead of the int function this time. The reason is that the user might enter a decimal number like 3.5. If we had used int, Python would give an error whenever the user enters a decimal number. But float handles both whole numbers and decimal numbers perfectly. Let's run the file again and put a decimal number. Let's give the first number 12 and the second number 2.6. You can see that it runs perfectly and does not give errors. Suppose we had used int, Python would give an error. So when you are not sure whether the user will enter a whole number or a decimal number, it is safer to use float function for the conversion. Now let's build another practice program. This time, let's build a program that asks of the user's age and birth year and then calculates their approximate age. Let's create a new file called agecalculator.py. Switch to insert mode and let's type some codes. Press escape, then save. Run the file. Let me type my name, Additional, then press enter. Now, let me type the birth year, 2000, and press enter. You can see that the program calculated the approximate age and displays it with a friendly message. This is a real program. It takes information from the user, processes it, and gives back a useful result. We can run it again with different data. Let's give the name a value of good news and give the birth year to be 2001. You can see that it works perfectly. Now, let's learn about one situation that can cause problem with user input. What happens when the user types a wrong kind of data. For example, what if our program asks for a number but the user types the word instead? Let me show you. Run the user.py again. When it asks for the first number, let me type the word hello instead of a number and press enter. You can see that it gives a value error. It says it cannot convert the string hello to a float because hello is not a number. This is something to be aware of. In a more advanced program, we will handle this error gracefully, meaning we will catch the error and show the user a friendly message instead of letting the program crash. We will learn how to do that when we get to the topic of exception handling later in this course. For now, we will assume that the user always enters the correct type of data. Let's do one more practice program before we push to GitHub. Let's build a program that collects some personal information from the user and displays it back in a neat format. Let's create a new file called profile.py. Switch to insert mode and let's type some code. Press escape, then save. Let's run the file. Let me enter details one by one. You can see that after I enter all the information, the program displays it back in a neat and organized format, like a profile card. This is a great example of how user input can be used to make program feel personal and interactive. Now, let's push everything to the GitHub. Let's go and check the GitHub. You can see that all new files have appeared in the repository.